Okay, in this third video, we're going to take a look at how we calculate percentage uncertainties. And again, I do highly recommend, if you haven't, you need to watch the first video on resolution of instruments and the second video on absolute before you undertake this work. There's two learning objectives in this section. The first one just being really what the percentage uncertainty of an instrument is and what it represents. And then secondly, we'll do a couple of assessment questions to give you expertise and experience of undertaking these types of calculation. Now, again, in some types of questions, you are required to determine the percentage uncertainty of an instrument or measurement really that you've taken. And to do this, you'll need to utilize the following equation. And so your percentage uncertainty is equal to the resolution of your instrument, which we've covered back in the first video series, divided by your measurement and then multiplied by 100. Now again, you might want to pause the screen now, just write down these notes before we continue on. Now, in relation to significant figures for percentage uncertainty, just before we go any further, I just want to note that you are advised to give your percentage uncertainty to two significant figures. Again, I just want to copy down these notes before we progress. And here's just a wee quick screenshot of two papers I've worked on in the past, and you can see the left hand side there, percentage uncertainty. And again, the answer is required to two significant figures. And then the second answer here is also to two significant figures, but they were accepting each till one significant figure. But again, I highly advise to give it to two, please. Okay, I want you now to pause the screen to copy out this question and have a go at determining the percentage uncertainty of this measurement of 260 millimeters. Now again, first thing, write down the equation. The percentage uncertainty again is just the resolution of your instrument divided by your measurement and then multiply it by 100. Again, we do need to understand what the resolution of an instrument means in this case. And again, that's where series 1 came in the first video. And so this is a ruler that measures to the nearest 1 millimeter. And so we take the resolution to be 1 millimeter. You divide it by your 260 times 100. And that gives me these long string of digits here. Now, you wouldn't have to write down as many significant figures in the exam, before you get it down to 2. I've just put down exactly what my calculator has shown here. And then of course we need to narrow that down to round it to two significant figures, which in this case is 0.38%. We can now quote this length as being equal to 260 millimeters plus or minus 0.38%. And again, if needs be, you can pause the screen and copy down the full solution or make any corrections you need to. Worked example 2, I just want you to pause the screen, copy out the question and have a go at doing this worked example yourself. Okay, and again, always recommend to write out the equation you utilise. If we sub in the respective numbers, you can see in this case this ammeter is recording to 2 decimal places or 1/100th of an ampere. And so the resolution is 0.01 divided by the 2.14 times 100, and that gives us this answer here. Again, I personally would write down the full string of digits. Just be careful that you don't make any mistakes there, double check. You can of course make small errors and copy the number from your calculator down onto your page. Now we can finally round that to two significant figures, and we can now quote that current as being equal to 2.14 amperes plus or minus 0.47%. And again, you might want to pause the screen, make any corrections, but hopefully it should be okay after doing the first worked example. Worked example 3, again, if you want to pause the screen, copy it out and have a go at it yourself. And again, equation, if you sub in your resolution, this one is only measuring the nearest tenth of a volt or 1 decimal place. That's what a resolution is divided by your reading times 100, giving us this percentage uncertainty. And then again, round that to two significant figures. Be careful again there, that's 6 before the 0, it must be rounded up. And again, we can now say, look, this voltage is equal to 12.4 volts plus or minus 0.81%. And again, you might want to pause if necessary to copy down any corrections. Now, if you've taken a number of different results, so let's say for instance you didn't just measure the length once, you measured it several times, and you then of course calculated the average of those lengths, as we did back in the second lesson on absolute uncertainties, we need to utilize this equation here. And your percentage uncertainty is now equal to your absolute uncertainty, which you've done back in topic 2. That's pretty much as we've seen plus or minus half the range of results, top bottom. You split that in two, you can go up half, down half, and you input in your average value you've got, and you multiply it by 100. Now again, if you just want to pause the screen, copy out the respective notes, we're then going to really tap into some of the previous questions from the second lesson and use them as a basis for determining the percentage uncertainty. Right, so going back into the second lesson, we came across an example where 4 measurements of length were taken, and we've seen the average length was worked out to be 143.5 millimeters, and the absolute uncertainty was plus or minus 1.5 millimeters. We've seen the total range from top to bottom was 3, and of course we divided that in half and said, look, you can be half up or half down. So again, this 143.5 millimeters represented the average length from those 4 measurements, and the 1.5 millimeters represented the absolute uncertainty. And again, you can go back through your notes from the second lesson to see exactly how we arrived at these numbers. Now we're going to use these numbers as the basis for our next calculation. So I do recommend to pause this, write this down, the supplementary notes too, and then we'll try and do a calculation to get the percentage uncertainty in the readings we've just taken. Okay, so using those particular values, the 143.5 millimeters plus or minus 1.5 millimeters for the absolute uncertainty, pause the screen, copy out the question please, and have an attempt yourself at determining, calculating really the percentage uncertainty for this measurement. First thing, again, write down the relevant equation please. Sub in the respective numbers. Again, you can see the absolute uncertainty. This is the 1.5 millimeters. Your actual average reading, 143.5. And I do recommend this calculation to put in the actual values, whatever number of decimal places you have, not the rounded final answer that we discussed in lesson 2. It just means you're more accurate in relation to your final value. Now that's going to give us this big long string of digits in this case, roughly 1.05%. I do recommend again to write that out fully, or quite a large number of digits, and then finally we can bring in that length. So the length is now equal to the 143.5. Again, we want to put the full string of digits in there. The same with your percentage uncertainty as well. And finally at the end then, we want to do that rounding. And as we discussed back in the second lesson, we want to round that length to the resolution of the instrument, which is 1 millimeter. So that rounds up to 144. And we want to express our percentage uncertainty to 2 significant figures. And because the third digit's a 4, of course we must round. Just keep that as a 0. There's no need to round up. And if needs be, you can pause the screen and do any corrections as necessary. Have a little go now at this 5th worked example. You're given a current, which worked out to be the average from a number of readings, and the absolute uncertainty was 0.07 amperes. You're also told here that this particular current meter did record the 2 decimal places, so it records the nearest 1/100th of an ampere, and please determine the percentage uncertainty of this measurement. Pause the screen, copy it out, have a go please. Again, if you write out the respective equation, if you now sub in the respective numbers, 0.07 divided by 2.12, That's what the percentage uncertainty is equal to. Again, just be careful copying those numbers out. Double check if necessary. We tick maybe in your wee answer just to make sure you've done that with a pencil. And then of course we can say now, look, your current is equal to 2.12 amperes plus or minus this long string of digits. Now there's no need for me when I'm expressing my final answer to change the current because it's given to the appropriate number of decimal places. Remember, the resolution of the ammeter was to the nearest hundredth of an ampere. That's perfectly fine. And I've rounded my percentage uncertainty to 2 significant figures. That should be fine as well. And if needed, you can pause the screen and make any corrections as necessary. And that really should hopefully tick off the requirements of this wee lesson. So hopefully now you're familiar really with what the percentage uncertainty of an instrument means, how to calculate them of course for a single measurement, and the last 2 worked examples of course covered when you've got a number of measurements taken in some of the knowledge from lesson 2. And that really concludes the information for this respective lesson then.